All right, this is a tutorial on the Big Ideas Geometry, section 8.4, Proportionality Theorems. So hopefully by the end of this, you will be able to use the triangle proportionality theorem and its converse, and use other proportionality theorems. So the triangle proportionality theorem is pretty self-explanatory. You're setting up proportions within triangles, but more specifically, a line inside a triangle that is parallel to one side of the triangle and it intersects the other two sides. Then it divides the other two sides proportionally. So in this diagram, you have a triangle with two parallel lines. You have line QS and TU are parallel. It actually sets up a proportion comparing RT and TQ are proportionally equal to RU and US. So those ratios of the two sides that are connected but cut by this line TU are going to be the same ratio or equal in a proportion. So let's look at this in an example. In the diagram, we have given that QS is parallel to UT. We're given that RS is 4, ST is 6, QU is 9, and we need to find the length of RQ. So we're trying to identify the length of this line of the triangle right here. Well, based on the triangle proportionality theorem, because those two lines are parallel, you can set up a proportion of the top left equal to the bottom left, the top right equal to the bottom right in the same ratio. So we're going to plug just those numbers and those units into each other. So RQ is what we're still trying to solve for, so we leave that one blank. 9 is equal to QU, 4 is equal to RS, and 6 is equal to ST. And then we are solving by cross multiplying. So multiply both sides by 6 and 9, and then divide both sides by 6, 30 to get 6 is the length of RQ. Okay, looking at this on a real life problem. So given a shoe rack where the length of BA is 33 centimeters, CB is 27 centimeters, CD is 44 centimeters, and DE is 25 centimeters. Explain why the shelf is not parallel to the floor. So we need to be able to do the opposite and set up a proportion and prove that these are not equal to say that BD is not parallel to AE. So let's set up the ratio of each of the lengths. CD and DE are on the same right side of this triangle, this line segment. So those two go together in a ratio. 44 on top, 25 on bottom. Then on the left side, CB and BA go together. 27 is on the top because it's CB. Don't be confused by the order of which they are given to you in the description. Look at the diagram and it'll tell you where everything is, so you can keep it in order. And this ratio can be reduced to 9/11. Since these two ratios are not equal, the line BD does not create a proportion in the triangle, and the line BD is not parallel to AE. Okay, so using three parallel lines, think back in chapter 3 when we had two parallel lines cut by a transversal. This is kind of extending upon that, but not looking at angle measurements. It's looking at lines and proportions of those line segments. So if we have three parallel lines that intersect two transversals, then they divide those two transversals proportionally. So your three parallel lines are moving vertical RST, and then your two transversals L and M. We don't know if they're parallel. They could be, but based on the diagram, it looks like they're not because they're not marked parallel, but that doesn't matter. What does matter is that these three lines are parallel. And what happens is the distance from UW over WY is the same proportionally as VX over X and Z. So you can kind of connect the two intersections on one of your transversals and then compare that in a proportion with the other transversal. So in this diagram that looks like a city street map, we have angles 1, 2, and 3 that are all congruent, which could mean that some of these lines are parallel. We're given that GF is 120 yards, DE is 150 yards, CD is 300 yards. We need to find the distance HF between Main Street and South Street. So we're trying to identify this distance right here, all the way from South Main Street to Main Street up here. All right, so since those angles 1, 2, and 3 are corresponding, your two transversals are these vertical and diagonal lines. but your horizontal lines, FE, GD, and HC are all parallel to each other. So there are a couple different ways you could write your proportions. You could say HG over GF, comparing this first line, and CD to DE. You could have those flipped. You could put GF on top and DE on top, but the order just needs to be consistent with how you are setting it up. So since we don't know what HG is, we're going to substitute everything else that we were given in the description. So we know that GF is 120, so we're going to plug that in there. We know that CD was 300 and DE is 150. Just go ahead and cross multiply, simplify by dividing, and get that HG is 240 yards. So that is just HG. Now the question is asking us to find the distance HF between Main Street and South Street. So we need to take this 240 yards, add that back to our GF of 120 yards to get the grand total of 360 yards for the distance. So step 2, or your option 2, could be to set up a proportional involving your total and your partial distance, and then making up a table comparing all of those together. So you know that HF is going to be your total distance. Create a proportion of adding your total distance of C and E, which you get from 150 plus 300 to get 450, and then your DE is 150. The 120 comes from your GF, and then you would cross multiply and solve to get 360. Either method gives you the exact same answer, so it does not matter which one you choose, whether you're using a partial over total or just partial for all of them consistently. Last theorem we're going to look at in this section 8.4 is the triangle angle bisector theorem. If a ray bisects an angle of a triangle, which means it is the angle on both sides of the ray are congruent, then it divides the opposite sides into segments where the lengths are proportional to the lengths of the other sides. So if this red line creates congruent angles on both sides, then you've created a proportion of AD and DB is equal to the two sides that the ray does not touch, AC and CB. So let's look at this into a example. So we're given that angle QPR is equal to RPS, so that means that that line PR is an angle bisector, and we're using the given lengths to find the length of RS. So we are trying to find from this red line down to S. We're given the whole thing is 15. We're given PQ up here is 7, and PS is 13. So we're going to use our triangle angle bisector theorem to create a proportion using X for this side and 15 minus X for the QR. Because remember, 15 is the whole thing. And if you want to take away this X part, you just subtract 15 minus X to get your QR. Set up a proportion, RQ over RS, because those are the two sides that your angle bisector is cutting. And then the other two sides, PQ and PS, in that order. So substitute those things in. 15 minus X over X, and 7 over 13. So when we cross multiply, you need to make sure that when you're multiplying your 13 times 15 minus X, it is a quantity, so that's parentheses. And that means you need to distribute your 13 times 15 to get 195, and 13 times negative X to get negative 13X. Then you got 7X for the other one. Add 13 to both sides to get 20. And then when you divide 195 by 20, you get 9.75 as the length of your X.